Problem number 3 asks us how many atoms of hydrogen are there in 3.4 moles of H3PO4. I'm given 3.4 moles of H3PO4 phosphoric acid. And I'm asked to figure out how many atoms of hydrogen I have in this 3.4 moles. Well, first of all, I cannot directly relate the moles of hydrogen or phosphoric acid to atoms of hydrogen. And I can't do that. I can't relate atoms of hydrogens because I don't have the moles of hydrogens. I only have moles of phosphoric acid. But I can relate the moles of phosphoric acid to moles of hydrogen directly. In lecture, we said that if I have one molecule of H3PO4, I will have 3 molecules, so I have 3 times as many hydrogen atoms. That's what that 3 tells me. If I have 10 molecules of H3PO4, I will have 3 times as many hydrogens, which means I'll have 30. If I have 1 mole of H3PO4, I will have 3 times as many hydrogens, so 3 moles. The ratio is 1 to 3. Therefore, if I want to convert moles of phosphoric acid to moles of hydrogen, I use that 1 to 3 ratio. Note that we can do this for any of the other atoms in phosphoric acid. I can say that the oxygen to phosphoric acid is 4 to 1 ratio. The phosphorus to phosphoric acid is 1 to 1 ratio because I only have a 1 here, which is not written. 3.4 moles of H3PO4. To convert that to moles of hydrogen, I use the 1 to 3 molar ratio, which means I want moles of hydrogen on top, and I want to get rid of moles of phosphoric acid, so I want that at the bottom. Therefore, I know that 1 mole of phosphoric acid gives me 3 moles of hydrogen. Therefore, the moles of phosphoric acid will cancel, and this will give me 10.2 moles of hydrogen. 3.4 moles of phosphoric acid are equivalent to 10.2 moles of hydrogen because I have 3 times as much hydrogen as I do phosphoric acid. But the question doesn't ask me how many moles, it asks me how many atoms. Now that I have the moles of hydrogen, I can use my relationship here with Avogadro's number and the mole to convert to atoms of hydrogen. Let's do that. 10.2 moles of hydrogen, and it's multiplied by my conversion factor. Let's think about what we want on top is the atoms of hydrogen, and I want my moles of hydrogen to go away. So 1 mole of hydrogen has 6.022 times 10 to the 23rd atoms of hydrogen. My moles of hydrogen will cancel, and if I multiply that, I should get 6.1 times 10 to the 24th atoms of hydrogen. Okay, let's take a look at the last problem, number 4. How many moles of benzene, C6H6, are there in 6.78 times 10 to the 20th atoms of carbon? What am I given? 6.78 times 10 to the 20th atoms of carbon. Now, if I look at the molecule that I'm given, I notice that I have 6 carbons for every molecule of C6H6. Therefore, I can relate just like up here, except I'm going backwards. I can relate the moles of carbon to moles of C6H6. However, I don't have moles of carbon, I have atoms. Therefore, I have to convert to moles first, and I do that by using Avogadro's number up here. Okay, I'm converting atoms of carbon to moles of carbon. Therefore, I want my moles to be on top. 1 mole of carbon contains 6.022 times 10 to the 23rd atoms of carbon. My atoms of carbon will cancel out, and this will give me 0.00113 moles of carbon. That's how many moles of carbon are contained in this many atoms, 6.78 times 10 to the 20th. 1 mole has this much, but I don't have that many atoms. I have much fewer. Therefore, I will have less than 1 mole of carbon, which is correct. I've done it correctly. If you had gotten a huge number, that meant you had inverted this and you had multiplied by Avogadro's number instead of dividing. Now that I have moles of carbon, I can relate that to moles of benzene, C6H6, because I know that if this is my formula, C6H6, for every 1 molecule of C6H6, I have 6 carbons, so it's a 1:6 ratio. Let's convert from moles of carbon to moles of benzene. Start with what you are given, 0.00113 moles of carbon. And now I used my 1:6 ratio. Remember, what I want on top is moles of my benzene, C6H6, and I want my moles of carbon to go away. I write the moles of carbon on the bottom. Mole carbon, 6 moles of carbon for every 1 mole of benzene, C6H6. My moles of carbon will cancel, and if you do this division, you should get 1.88 times 10 to the minus 4 moles of C6H6. Okay, this is how you can work out these types of problems. You can relate the number of atoms to moles of that particular substance, or even atoms within a molecule, like we did the last couple of examples. Remember, if you are given a large number, so number of atoms, and you want to go to moles, you divide by the Avogadro's number, because moles is a much smaller, so I have 1 mole equal to this huge number. If I'm going from huge numbers of atoms to moles, that means I'm going from to a larger unit over here, so I'm dividing by my Avogadro's number. If I have number of moles and I'm going to look for atoms, then I multiply by Avogadro's number. It's similar to going from 1 foot has 12 inches. So if you have 50 inches, let's say you have atoms, 50 inches, and going to feet, you divide by 12. If you have 3 feet and you want to, so 3 moles or 0.113 moles, and you want to figure out the atoms, you then multiply by Avogadro's number. So if you have 3 feet, you're going to multiply by 12 to get the total number of inches. This is a similar type of relationship. Okay, this concludes the problems on this slide.